Hello everyone, I am Amit Maru and today in this video we will discuss about C program for insertion sort algorithm. So let us start our today's video on C program for insertion sort algorithm. The prerequisite of our today's video, that is a C program for insertion sort algorithm, is you must know whole insertion sort algorithm first, then you can easily understand our today's video. So I am requesting to all the students, please watch my video on insertion sort algorithm. The link of this video is given in this video in description, so please watch this video. In that I have given whole insertion sort algorithm with one example, so that you can understand today's video easily. So please, again I am requesting to all, please watch my video on insertion sort algorithm, and the link of this video is available in today's video's description. So take this link and watch this video, and then watch today's video on C program for insertion sort algorithm, so that you can easily understand today's video. So let us start our today's video on insertion sort algorithm. So before starting off our C programming of insertion sort algorithm, I would like to give a brief idea about insertion sort algorithm, or we can say the basic logic of insertion sort algorithm to sort list of number into ascending order. So suppose we have a list of number like 9, 5, 3, 1 and 20. This is the list of number, and we want to convert list of number into ascending order by using insertion sort algorithm. So as per the logic of insertion sort algorithm, we have to start from the second element. So second element of this list of number is a 5. We have to consider this second element as a current element, and then after second time we have to move our current position from second element to third, then after fourth, and then after fifth, like that, right? So our initially our current position is nothing but our second element. As per the logic of insertion sort algorithm, we have to compare our current element with the previous element. If the current element is less, or we can say the previous element is larger than the current element, then we have to compare current element with previous of previous. So the previous of previous, there is no element here, so we have to stop here, and we have to just move, or we can say we have to insert a 5 on our first position, and we have to shift 9 by 1. So 9 will be moved here and 5 will move here, and remaining element will be as it is. So 5 will move here and 9 will move here, and remaining elements are as it is, like 3, 1 and 20. Now our current position is a third element, that is a 3 in our example. So again we have to perform same operation. We have to compare with the previous of our current element. This is our current element, and previous of current element is a 9. 9 is larger than the 3, so we have to again compare current element with previous of previous. So previous of previous is 9, which is again larger than the 3, so we have to compare a current element with previous of previous. So there is no previous of previous element, so we have to stop here, and we have to move our current element on this position, or we can say first position, in place of 5, and we have to shift 5 and 9 by 1. So 9 will be shifted here, and 5 will be shifted here, and 9 will be shifted here, and 3 will move on current move on first position. So 3, then after 5, then after 9, and remaining elements are as it is, 1 and 20. Now our current position is our fourth element. Again we have to perform same operation. We have to compare with the previous element. Previous element is 9, and the 9 is larger than the 1, so we have to compare with the previous element. 5 is larger than the 1, so we have to compare with the previous element of 5. So 3 is larger than the 1, so we have to compare with the previous of previous element. There is no previous of previous element, so we have to stop here, and we have to move our current position on this location. So 1 will move here, and remaining element like 3, 5 and 9 will shifted by 1. So 3 will shift here, 5 will be shifted here, and 9 will be shifted here, and 1 will move on first position. So 1 will be inserted on first position. So and the remaining element like 20 as it is. So we can get next the list, that is a 1, 3, 5, 9 and 20. Now our current position is the last element, that is our fifth element 20. So again we have to compare with the previous elements. If a previous element is larger, then we have to compare with previous element until we get number which is less than the current element. So we have to compare with the previous element. So previous element is not larger than the current element, so we cannot now compare with previous element, because once we compare, then it will be less than the 20 only. So we have to just compare with the previous element. So 9 is less than the 20, so we have to directly stop here. We are not moving anywhere. We have to stop, and we have to move our current position, but there is no any other element in this list, so we have to stop here. And this is the list of number into ascending order. So 1, 3, 5, 9 and 20. This is the list of number into ascending order by using insertion sort algorithm. So this is all about basic logic of insertion sort algorithm to sort the list of number into ascending order. So let us start our C program for this insertion sort algorithm. So as you know that first step is we have to insert some header file. So our first header file, that is stdio.h, that is a standard input output header file. The standard input output header file basically use in standard input output header file there are number of input output functions. If you want to use any input output function in our program, then we have to include a standard input output header file. Second header file, that is console input output header file, because in our program we are using getch function. This getch function is available in this console input output header file. So if you want to use any function from this header file, then we have to include this file first. So we have included two files. One is standard input output header file and console input output header file. Now the next step is our void main, that is our main function section. We have to start from the main function section. So first step is void main, and then after we have to declare different variables as per our requirement. So here we are declaring two variable. One is integer n and second one is integer I, and we are taking one array, that is t of 10. Here you can declare any size. Here we have declared only 10 elements, so maximum we can store 10 element in t array, but you can use a maximum size of array, so that you can sort maximum number of elements. So here are three variable we have declared. One variable is n, second variable is I, and third variable is nothing but the array which has a size 10. All are integer number. This n basically used to identify how many elements you want to enter, because before starting off our program we have to ask to our user that how many element he or she want to enter in our program. Now next one is as we are making insertion sort algorithm, so we have to make one function. The name of the function is insertion sort. In that we will pass integer variable as well as integer array. So this is known as prototyping of the function. This whole function will be available in this program. So this is the declaration of function. Then next is a clear screen to clear the screen from the in the output, so that we can easily clearly check our output. Next one is a printf, how many number you want to enter. That is the one message that we need to display on the output screen, and we are asking to user how many element our user want to enter. And then we are using scanf to enter different values inside the n. So our user enter for example 8, then 8 will be stored in our n. So n is equal to 8, it indicates that our number of element inside the array will be 8. So we have to store 8 different elements inside the array. So now we have to enter different elements inside our array, so that we are taking one loop, and this loop will be executed n times, because n number of elements we are going to store inside our array, capital T. So now we use one scanf function to store different element inside the array. So scanf %d ampersand t of I. So t of first element will be stored in our t of 1, then after t of 2, then after t of 3, then after t of 4, up to the n element. Suppose we have entered n is equal to 8, then this loop will be executed 8 times and 8 element will be stored inside our t array. Now we have to call one function, that is insertion sort. This is our insertion sort algorithm. So the name of the function is insertion, and in this function we are passing two arguments. One is n, that is the size of our array, and capital T is nothing but our whole array. Then the last statement, that is a get ch, and we are closing the function. Now outside this main function, we have to write a body of the our basic function, that is insertion sort. As we discuss, we have to pass two arguments. One is a size of array and second one is a whole array. So size of the array is n will be stored inside the another variable, that is n. In place of n, you can use any other variable name also. In place of capital T of array size, we are not here declaring the size because this n indicates the size of capital T, and in place of T you can use any other name also, but we have written same name n and capital T. So this n will be stored inside this n, and the whole array will be stored inside this capital T array. Now inside this insertion sort function, we have to declare three local variable like I, j and x, because we are going to use nesting of loop. So our outer loop will have an index I and inner loop will have an index j, and x variable we are using to store the different values, that is a temporary value. Now after completion of a whole loop or logic, we will have a list of number into ascending order. So we are printing one message, that is sorted elements are. So then after we will have a list of number into ascending order. Now to sort this number, we have a logic, that is our insertion sort algorithm, as we already discussed one example. So in this example, as we have discussed, we have to start from the second element. So our loop will be started from the I is equal to 2, and this loop will be executed up to the last element. So I less than or is equal to n. Every time this loop will be increased, the value of I will be increased by 1. Now take one variable x is equal to t of I. So the second element will be stored in our x, so that we can compare with the previous element. Now take another variable j is equal to I minus 1, because we want to compare with the previous element every time. So x I we have started from the 2, that is our current position, and j will be our previous element. So j is equal to I minus 1. This is our previous element. Now take another loop, that is a while loop. In this loop we have one condition, that is j greater than 0. It means that we have to move previous element until we get first element, or we can say the element which is less than, until we get element which is larger than the current element. Once we get element which is less than the current element, or once we get our first position, then we have to stop. So here we have to give two conditions. One is j must be greater than 0 and x less than t of I, t of j, right? So either we can get our first element once we move previous element, once we move previous to previous, previous to previous, at that time we have to stop when we get first position, or when we get element which is less than the current position, then we have to stop. So in both the condition your loop will be break, or we have to stop. Now inside this body of this while loop, as we discuss, we have to shift our element on previous to previous, previous to previous, according to the element which is greater than the current position, right? So we have to perform t of j plus 1 is equal to t of j, and every time we have to reduce the size of our j, so that we can get every time previous of previous, previous of previous element, like that. And this loop will be executed based on these two conditions, j greater than 0 and x less than t of j. Once we stop, then we have to shift our current position, or we can say the current element on the t of j plus 1 is equal to x, and then we have to stop. Now the value of I will be I is equal to 3, so our current position will be 3, and same operation we have to perform. We have to compare with the previous element, then after previous element, based on these two conditions, j greater than 0 and x less than t of j. Then after current position will be 4 when the value of I is equal to 4. Again we'll perform same operation like previous element based on these two condition. Then after current position will be 5 when the value of I is equal to 5, and this loop will be executed I less than n time. At the end of this for loop, we will have a list of number into ascending order. Now let us check this number is in ascending order or not, so that we have to display the value of t, and to display the value of t, again we have to take one loop. The loop will start from I is equal to 1 to I less than or is equal to n I plus plus, and in this loop we have to display a value of t. So this use a printf function to print the value of t, printf %d t of I. So when the value of I is equal to 1, will display t of 1, value of t of 1, then after t of 2, t of 3, t of n. So in this way we can display all the values of our t array, and this value will be ascending list. So now let's run this program. So as we discussed, first we have to ask number of elements from the user. So how many number you want to enter? For example, user enter 8. It means that we have to enter total 8 elements inside the array. This is the random list of number like 5, 3, 9, 1, 8, 7, 4, and suppose 6. Then the list of elements will be 1, 3, 4, 5, 6, 7, 8 and 9. This is the list of number into ascending order. So this is all about insertion sort algorithm to convert list of number into ascending order. So thank you very much for watching this video. Again, thank you very much.